Okay, this is pretty typical of the problems that you'll see on the quiz. So we're given a function f of x equals negative 2x, and we're asked to find if it's odd or even using the definitions. So basically the same thing as we have above. Let's take a look at odd. Sorry, let's start with even. It's easier. And remember, even says that f of x is going to be equal to f of negative x. So on the left-hand side, here's my f of x. On the right-hand side, I'll put in a negative for x. And right away, you see that I get a negative 2x on this side and a positive 2x on this side. So it's not even. Let's take a look at odd. Same idea. On the left-hand side, I'm going to plug in a negative x everywhere I have an x. And on the right-hand side, I'm going to make the whole darn function even. Or sorry, make the whole darn function negative. So I get a positive 2x on the left-hand side and a positive 2x on the right-hand side. It is definitely, not an even function, an odd function. And when you take a look at it's a pretty simple function, negative 2x, we get this, which if you take our function and flip it over the y-axis and then flip it over the x-axis, you will get the exact same function. All right, last one is example 2. This is an odd function. I'm going to run through the even just for the practice, I guess. So on even I start out with the original function on the left. It doesn't really matter as long as you do your substitution, but I tend to do things. So negative x on the right. Okay, simplifying my signs, my left-hand side stays the same. When I take negative x to the third power, I'll get negative x to the third. And I get a positive x out of this. So this means this is definitely not an even function. As soon as the negative x and the positive x show up, I'm done. I don't have to do anything else. So not even. Okay, it will pass the odd test though. So let's do the same thing. I'm going to put in a negative x on the left-hand side everywhere I've got an x. And on the right-hand side, I'm going to put a negative in front of the whole function. So if I simplify, then I'm going to get a negative x to the third, so that goes positive. And on the right-hand side, distributing that negative on the outside of the parentheses to both terms also gives me a positive. So it is an odd function. All right, on to the next kind of idea in this chapter. We're asked to find the average rate of change on the interval. Well, it turns out the average rate of change is just slope. Okay, and remember, slope is the difference in our y's over the difference in our x's. And what we have to do then, in order to get the difference in the y, is we need to calculate using our function at both values of x. So what I'm going to do is I'm going to show you kind of the most efficient way to make it through these problems. I'm going to label this x1 and x2. Just labeling that keeps me from making, dumb sign errors. And my formula for the average rate of change is just the slope, but I'm going to write it slightly differently. I'm going to use this terminology, or this symbology. When I put a bar over a variable, it means average. So I'm going to use this to, instead of writing slope, because we're using it to answer the question about average rate of change, but we really are calculating slope. So my y2 is just going to be f of x2 minus f of x1 all over x2 minus x1. Because if I plug in x to my formula, I have my y. So I'm setting it up this way so that this next step makes sense. So I'm going to write my, I'm going to write 4x plus 1 minus 4x. X, I want to leave that open because I'm going to put a number in there, plus 1. Now the reason I'm using parentheses on the second expression is because I have that subtraction and I have more than one term, and if I don't use those parentheses, I'm probably going to forget to do that. Okay, so x2 is 5, and x1 is negative 2, and in the denominator, I'm just going to have x2 minus x1. Okay, so let's do some simplifying here. We get 20 plus 1, or 21 in the numerator, minus, looks like 4 times negative 2 is negative 8, plus 1 is negative 7. All over 5, and minus a negative 2 is 5, plus 2, or 7. So 21, let's simplify my signs here. 21 minus a negative is going to be 28. So I get 28 over 7, or 7 goes into 28 4 times. So my average rate of change on the interval between negative 2 and 5 for this particular function is 4. And I'm going to stop the video. I'll see you on the next one.